Okay, so this is form 3. We just started to look at this topic, but we didn't take it further. So I thought it's important that we should restart the topic, because I know we have taken so much time before doing this. So what we are going to do is actually what you call the properties of matter. Okay, so we'll do what you call the properties of matter as the topic. Many muli topics, ma subtopics angapo mulizo kuza the kinetic field of matter, muli pressure, muli thermometry. Yeah, so ndezina zingapo zokuza matter. So unit yoyamba kuyiona ndi unit yokuza ma properties of matter. Okay, okay, so obviously what we are going to learn is that we should be able to explain the kinetic theory of solids, liquids and gases, and also should be able to explain the discuss the relationship between the speed of molecules and the temperature, and then we'll explain the term the absolute temperature. That's what the syllabus tells you to do. So let us now define the word the kinetic theory of matter. Okay, so when you talk of the kinetic theory of matter, the word kinetic comes from the Greek kinetic. The word kinetic, it comes from the word kineo. It's a Greek word, kineo, K-I-N-E-O. It's a Greek word. So this Greek word, in Greeks, it means I move. So if I say kineo or kinetic, so it means I move. Okay, that's what the word kinetic means. So the thing is, as I said, that the term. So what does the kinetic field of matter state? The field of matter says that inside the particles, and those particles are always in motion. Okay, so the kinetic field of matter says that inside matter, or the matter is made up of small particles that are always in motion. Okay, that's what I'm trying to say. Like with any kind of substance that you can see, there are small particles in it, and those small particles, they're always in motion. If you say they're always in motion, I mean they move. They continuously move. That's why it is called kinetic, because the kinetic means I move. So inside the matter, but do you know the meaning of matter, right? mass and occupies the space. So if you see something has got mass and occupies the space, what I'm trying to mean is that if you take something like a book or a stone or anything, press it somewhere else, it's going to take up a space on that particular place. Ndekuli chinthu chomwe chikazikana pake chitenga cover space nake. If it can occupy a space, it means it is a matter. And if that kind of thing can have mass, it means to find out how much does this one weight. So that's what we are trying to mean. So this theory says that matter is made up of small particles that are always in motion. Okay, so I think you are able to understand. So now let's talk about the properties of solids. These are just straightforward things because we have been doing the same since I think primary school. That closely kwambiri. Okay, so it's not something that you can be wasting much time because that's what you know. My properties, my particles are well packed together, meaning to say that the shape cannot be changed easily. You can at least tell kuti shape yake ndi ya round or ndi ya or it's ya four corners or it's rectangular shape like that. Solids have got a shape, something you can see, you can tell kuti shape indakula kuti. So that shape cannot be changed easily. That's what I'm trying to say, to be definite shape. Definite volume. So we say that solids cannot be compressed. Can compress. Let's say compression. Can someone tell me? Yeah. So ngapa nke kuli kufinyika. My particles of what I'm trying to say is that since particles of solids are arranged together very much close to each other, it means volume imene akuzotenga mass are closely packed. Now since if you talk of density is mass over volume, right? Density is mass of substance over volume. So if you say density of solids, it means if its mass is 20, It means they can take a small volume. They can take a small space. It means if you divide 20 by that small space, you're going to have a highest density, a highest number, a highest value. That means density of solids. Solids, eh? We'll squeeze is it? Yeah. Okay. Rigidity. Tikamba nkhani zokhudza ngati kulimbe. Solids are hard, eh? Okay. They are hard. Okay. Fixed melting point. Most of solids they melt at a specific temperature. So these are some of the points that you can give it. If they can ask you to describe the properties of solids, so you have to talk of shape, volume, density, and compressible. Okay, like kusiyana ndi mwana ku primary school. Okay. So let us now look at the arrangement of particles in solids. Alice screen muiona? Okay, that's great. So let us proceed. So talking of arrangement of particles in solids, so what did you know about the arrangement of particles in solids? Yes.
So particles are close to each other in solids.
Yes, particles are closely packed together. Okay, that's great. Ena tikuziwaja.
Particles do not move in solids. They remain in the same place.
Yes, they vibrate in a fixed position there. Yeah, that's great. Okay, so let us just see some of the arrangement of particles in solids. As I've said, Mr. Shisomo Query and your friend, particles are tightly packed. And there are strong intermolecular forces. Do you know these forces? Okay, the particles of solids are closely packed together. But these particles, to be packed together, they are held by some of forces of attraction that makes these particles to stay together. So these forces of attraction are what known as the intermolecular forces. So are forces that holds the particles together. Even in liquids, even in gases, there are these forces. But what differentiates is the power of these forces. So in solids, the power is very high. Is very high in solids. So these forces are the ones that hold the particles of solids together. The intermolecular forces, the IMF, the intermolecular forces. Also the International Monetary Fund here. We mean intermolecular forces, IMF. Ndafani bwereze fasi ntupanga pazi pati ndimene mafotokozera ma kinetic theory of solids. We use these kinds of arrangement of particles. Then number one, we have to know that okay, particles in solids are tightly packed together. Nizothinana kwambiri. Those particles are connected to each other by the strong intermolecular forces. These are forces of attraction that holds the particles together, that sticks the particles together. So in solids, these forces are very high. Okay? In solids, these forces are very, very strong, very high than in liquids, than in gases. Hope I'm clear. As I've said, the particles are in fixed positions. Okay? Like we can see in this picture. Sekundi chimanga cha tibibiri chiyani. Tokamba ma particles of solids, as you can see, are very, very packed together. So these particles that are packed together by strong intermolecular forces. Number one, my particles are tightly packed together in solids. And in solids, particles are held together by strong IMF, intermolecular forces. Now let us describe the kinetic theory of solids. Ndeno imene fotokoza pai ndi chimodzimodzi liquids ndi chimodzimodzi gas. It's just opposite. Points ake na amodzimodzi. As you can see this picture, what I'm trying to say is that this one is a particle of solid, this one is particle of solid, and these joints, these my bones, I want to my joints here, like my particles of solids. But between the particles, you can see that there is a bond. This bond is what you call it as an intermolecular forces. So these are the forces that are holding the particles together. I hope you can understand me, right? No. Let me explain the kinetic theory of solids. Number one, my particles awa amati akalandira heat. The heat energy that these particles can get makes the kinetic energy of these particles to increase. These particles, when they get heat energy, when they are heated, the energy from the heat increases the kinetic energy of substances, of solids. For example, if I say you are heating this solid, that heat energy, when it enters into the solid gains that energy when they get that energy, it makes use of it, and then it increases its kinetic energy. So tikamati kinetic energy, but I said kinetic, it means I move. It's movement. So if I say kinetic energy, it means energy for movement. So when the particles are heated, these particles increases their kinetic energy. Now once they get that energy, these particles now start moving, vibrating at the highest speed, but within their fixed positions, because they don't move anywhere. The particles, they just vibrate, they just move in their fixed positions, in their same places, without going anywhere. Now, a point is reached whereby these vibrations are greater and greater. When the vibrations are at a higher level, they make what you call the intermolecular forces to break. It means these chains that holds these particles together, they break. When they break, it's when you see that a solid is now changing the state from solid to liquid. A process known as what? Melting. Ndiye ukamankhasa kukoza kinetic theory of solids, number 1 mukhale point yokukoza kuti heating. You are heating the solid. After heating the solid is getting what you call the kinetic energy for movement. After getting this energy, these particles start moving and vibrating at the highest speed, but within their fixed position. But a point is reached where an increase in vibrations causes the intermolecular forces, the forces of attraction that holds the particles together, to break. Once they break, it's when you see a solid changing its state from solid and becoming a liquid. A process known as melting. Change from solid to liquid. Ndiye kandi ice uja kandi kendo. When you see ice, kumutrama za moto or kumusebena bag amambo kusungunuka, turning into liquid. It's the same theory. It's the same thing, the kinetic theory of solids. So the point should be, when solids are heated, particles gain more kinetic energy. The energy is ingayikundisima kuti no simungagwire ntchito, simungathamange before msanaje ndiye mujekaye kenanga muzithamanga. The particles akalandira heat ija makapanga heat amachita gain energy. Energy imene amachita increase the kinetic energy of what? Substances, of solids. So in solids, particles are fixed in place but can vibrate. With more heat, the vibrations become stronger and faster. As vibrations increase, the forces holding the particles together become weaker and zimaduka. At a certain temperature, vibrations are so strong that these forces of attraction can no longer hold particles firmly. Now it's when you see a solid starts to break down particles, and particles can move past each other. It means it has now melted, yasungunuka tsopano. This temperature is what you call the melting point. The temperature at which the substance melts. Can you understand me?
Yes, we are.
Yes, sir, we understand.
So, do you have
We
a question?
understand. Continue.
Yes, do you have a question on this? Before I ask you a question, do you have a question? Okay, so no question. So the question can be, describe why, what happens like if I say describe what happens for the candle to turn into liquid, why does candle amwe chadu yoya chimayatsaye, not candle Simon and candle. I'm talking of candle made mayatsai. Why do candles turn into liquid when we heat them? Why? Can you explain?
When solid after they vibrate, when there is more heat, it's stronger, everything weak with my bones. So after when it reaches the melting point, that means the temperature where it can melt, it can start to break into liquid or melt into liquid. It starts melting as I have stated. So that's how it really happens with the candle. When we hit the candle at a melting point, when we hit the candle, when it reaches that is melting point with the breaking down of my bones and also weak intermolecular forces due
Okay,
to heat.
my guy. Okay, I want you to explain to me as if I'm marking you. So if I can ask you, describe what happens for the candle to turn into liquid when it is being heated. This is a 5 mark question. So you should be telling me, I should be giving him a point. Like marks. When you give a certain point, I should be saying that you have getting 1 mark or 2 mark. So can you start again?
When heat is introduced to a solid, it starts to the particles starts to vibrate.
Okay.
1 mark.
Okay, I know. That's one.
Then I'll be it.
Yeah, I want you to get the marks.
Okay.
Yes.
So with increased pressure, increased heat, it causes it to move faster and faster in the molecular spaces, causing it to break the the intermolecular forces to weaken the intermolecular forces.
Okay. Yes.
So when it increases, when the heat still increases, it causes the breakdown of the bonds to the particles.
Okay.
Yeah, so when it reaches at the melting point, that's when we start, the candle start to melt due to weak intermolecular forces and also breaking down of bonds.
Okay, fine. So, okay, you're having the point, but the way you are trying to arrange the points, yeah, of course, I'll make it clear, but the points are the same. Okay, so yes, Magneva. Magneva.
Yes, ndugu Mveka.
Yes.
Okay. So the question needs us to explain why the candle melting after heating.
Yes.
So when we are heating, when we are applying heat to a solid, we
Yes.
increase kinetic energy to that solid.
Okay, specifically, you say
Therefore,
talk of candle.
yes. So a candle is in a solid state.
Yes.
So when we are applying heat,